Hello everyone. Welcome back to 10.1. Today we're going to do day 2, which you will be using quadratic functions involving inverse in real world situations. So we're going to be applying what we have learned yesterday and then involve the real world problems. So here we have. As we recall, in real world situations, you do not solve for the inverse and by switching the variables. Remember that? So therefore, the function y of x instead of f of x is just another notation to saying, that's just a different way of writing a function. So you can have f of x or y of x. The inverse function, it's easier to use that, I guess, for noting it's going to look like x of y instead of y of x. So the inverse, you will just see that x and y are switched. And so in this example, we're going to take a look at the function d equals 4.9 t squared. It gives the distance d in meters that an object dropped from a height with fall in t seconds. And express t as a function of d. Hint, solve for t. This is the inverse. So again, we are not going to switch any variables here. So using d equals 4.9 t squared, we're going to solve for t in this case. And the first thing we need to do is divide that 4.9, okay? And we got t squared equals d over 4.9. And finally, to undo the t squared, we have learned that the inverse of square is square root. So we're going to take the square root. And so now we have t. So t of d, but we're just going to write t equals the square root of d over 4.9. And that's part A, which means we have just finished expressing t as a function of d. Okay, and so here it is. And then part B, find the number of seconds it takes for an object to fall 150 feet. So that is going to be your distance that is given. So we're just going to simply substitute. So we are actually just looking for t of d, right? So another way to write this is t of d. And we're going to substitute the d that we have 150, which is t of 150, right? So we're going to substitute that into the function 150 over 4.9. And if you just use your regular calculator to take 150 divided 4.9, take the square root, it gives you an answer of approximately 5.5 seconds. So it takes about that much time for an object to fall from 150 feet. And that is the end of the problem. So we're going to try another one. Area is equal to, everyone knows this formula, right? Area equals pi r squared. It's the area formula for a circle. And so it's a circular object and the radius is r. Write the inverse r of a to find the radius r required for the area a, and then estimate the radius of a circular object that has an area of 40. So in other words, we're going to need to find the inverse by solving for r first. So the first thing that we need to do is get rid of that pi. So r squared is equal to a over pi. And to get r by itself, we're just going to take the square root. So we have r equals the square root of a over pi. So now this is r, or r of a, meaning radius as a function of area. And so now we got the radius function by itself. We're going to find the next step, which is to find the radius for a circular that has an object area. So we're given the area. And so we're going to substitute the area, which is 40 over pi. And pi is actually a number, so we can go ahead and use the pi function on your calculator. So take the square root of 40 divided by pi. You should have the radius, which is approximately 3.6 centimeters for an object that has an area of 40 centimeters square. And that's the end of the problem. So we have a really short lesson today, but let's, before we begin our assignment, have a look at this discussion question. What characteristics of the graph of a quadratic function tells you that the domain needs to be restricted in order for the inverse to be a function? So as you can see, whenever we have a many-to-one function, or when the output is repeated, then we know that we need to restrict it. So for example, the an example of this type of function would be the x squared function, right? Another one would be the absolute value function. Absolute value function, the graphs looks something like this. So the absolute value function would be another example. And so because we are taking the square root, it means that only positive values can go inside. So we are limited to, like, the minimum is 0 inside. So that's how we need to that's how we will know whenever you have a repeated output or a many to one function, we will need to restrict the domain for the inverse in order to have a valid inverse. And that's it for today. Let's go ahead and log into Google Classroom and get started with your assignment for today. And have a nice day.